This episode is rated PE. Your PE teacher's guidance is advised.
Hi class! Welcome to our Physiology virtual classroom. In episode 2, I ask you one question. What system of the body is responsible for your body composition? Now if your answer is endocrine system, you got it right. Your bloodstream is flowing with more than 50 types of hormones being secreted by different glands to control the biological processes from the smallest unit of your body to the body systems responsible for tissue growth and development, metabolism, energy production, storage processes, and a bunch of other functions including reproduction and sexual characteristics. Your appearance or body composition is just the most obvious, visible, and observable product of all hormonal functions inside your body. However, your endocrine system's work can be affected by several factors such as aging, puberty, diseases, stress, and even genetics. But let us not dive into the broad concept of endocrine system, as this is not my role as a PE teacher. Instead, let us focus on the functions of endocrine system related to body composition, food choices, and physical activities and exercise. So what goal did you set for your body appearance and structure in episode 4? What sort of things did you think of? Fasting? Strict dieting? More intense workout? Before we get there, you probably need to learn the science first. Don't worry, I'll keep it simple. In today's class session, let us learn more about food, the metabolic processes inside your body, and the types of physical activities and exercise that you should be doing in order to achieve your goals. You ready? Your body is a biological machine that needs fuel to sustain all of its complex body system functions. You get this fuel from the food that you eat every day. This fuel provides you with energy measured in kilocalorie, or simply calorie. In fact, it is estimated that 20% of the energy you get from food will be used by your nervous and musculoskeletal systems. You can expend this amount of energy through your physical activity and exercise engagements. 10% will be used for lifestyle physical activity, the things that you do to survive, like preparing meals, typing on the computer, and gardening. So where does the 70% go? The thing is, even while you are sleeping, your body is at a constant rate of expending energy. What do you think helps your hypothalamus maintain the temperature at 37 degrees Celsius 24/7? What keeps your lungs breathing? What keeps your heart pumping and your blood flowing through your blood vessels? What enables these functions that are happening inside your body? It's glucose, the energy source that you get from carbohydrates. When the pancreas senses that your blood glucose exceeds the normal level, it will release insulin to convert glucose into glycogen to regulate your sugar levels. This process is called glycogenesis. The liver is limited to store about 100 grams while skeletal muscles are limited to store about 500 grams of glycogen depending on your mass or your immediate energy reserves. If you're consuming more than how much your body can use, excess glucose will be converted into fatty acids. Now this process is called lipogenesis. In simpler terms, we call them body fat. Fat is stored in the adipose tissues, which can be found all over the body, under the skin, around internal organs, between muscles, and within the bone marrow. Now let's try going through a day or more without food. What would possibly happen? Let's assume that your last meal was your breakfast at 6 in the morning. You have nothing to worry about for 6 hours since your body is still fueled by the 2 cups of rice that you ate for breakfast. You will start feeling hungry at 12 o'clock. The receptors in your pancreas will sense that you are running out of glucose in your bloodstream, but because you skipped lunch, your pancreas will scream,
"Time for Plan B."
glycogenolysis. Your pancreas will release glucagon to prevent your blood glucose levels from dropping very low by converting stored glycogen into glucose. However, glycogen, your immediate energy reserves, can only sustain you for another 6 hours. At 6 o'clock, you skip dinner, your body will run out of glycogen reserves. Your pancreas will sense that your blood glucose is running out again. However, it can't do anything anymore, so the liver will take over to activate Plan C, lipolysis. Your body needs those fat stored in your adipose tissues for energy to get you through the day. Fats will be converted into ketones in the liver, and your body will go through a state of ketosis. This means that you're going to start burning ketones for energy instead of glucose or glycogen. Ever heard of the ketogenic diet? I am not sure how long you would last relying on ketones as a source of your energy. It would depend on how much fat reserves you have and the intensity of physical activities that you do while on ketosis. But after all those fats are all used up and all that's left are your lean muscles, still no food, your liver has to activate Plan D, gluconeogenesis, the amino acids which are the building blocks of protein. That means your muscles will be converted into glucose. I simply can't think about it. Your body will eat itself if you are not going to feed it. So, let's not get to that, or even beyond that. Okay? Your body has sequenced energy sources meticulously in order. It prioritizes glucose from carbohydrates. Then it will use glycogen stores in your liver and skeletal muscles. After that, your body will use fat reserves from your adipose tissues. And finally, the amino acids, which are your muscles. This corresponds to the food that you should eat, the macronutrients, carbohydrates, fat, and protein.
Hey, Oli G, you forgot about me.
Oh, sorry. What are you?
Creatine Phosphate.
Ah, so where are you from?
I'm inside your body, in your muscles, brain, retina, inner ear, sperm.
Okay, what do you do?
In case you don't know, you can't rely on glucose to perform powerful muscular contraction. You need me to generate power.
So you are saying that you are responsible for making me sprint, jump, and lift with power?
Yes, and even if I do that for 8 to 12 minutes, that doesn't mean you just have to take me for granted.
Oh, so how do you do that?
Ever heard of ATP?
Ah, yes, Association for Tennis Professionals, right?
No, that's not what I mean. I mean the adenosine triphosphate. ATP is the primary carrier of energy in your body. When the enzyme ATPase cuts out one phosphate molecule, it produces heat and releases energy. The ATP then turns into ADP, or adenosine diphosphate. The ADP gets one phosphate molecule back with the help of the ATP synthesis. ADP will turn back into ATP. It's basically just a cycle of ATP to ADP and then back to ATP all over again. Now what I do is different. Remember that I'm also a phosphate. I can also react to the ADP and together we can form an ATP.
Okay.
So when you use me in sports like sprinting or powerlifting, you are actually using Phosphocreatine energy system.
Oh, I see.
But just so you know, you have a limited amount of me inside you. So if you want to take me in as a supplement, you can. A According to studies, I can help you gain muscles and increase your strength and power.
I'll think about it, okay?
Sure.
Thank you, Creatine Phosphate. Oh, Glucose, you're here. What's up?
Ready to get you going.
Where are you from?
From the carbohydrates that you ate. Duh.
Which one?
You're from the Philippines. You tell me. You're eating noodles on top of rice.
Oh, shade. Well, tell me where you're headed to.
Sure. From your digestive tract, I'll jump to your bloodstream and get to a cell where I am needed.
Okay.
When I enter the cytoplasm of the cell, glycolysis turns me into 2-pyruvate, 2-NADH, and 2-ATP molecules.
So, ATP I already know. But what happens to the 2-pyruvate molecules and 2-NADH plus?
It would depend on you, if you work out intensely or you just take it easy.
What if I want to do intense workouts in the gym?
So here's what will happen to the 2-pyruvate and 2-NADH molecules. When you are contracting your muscles and there is no oxygen involved, you will feel that burning sensation. That is because of the hydrogen ions building up that increase the acidity in the muscles.
How about that lactic acid I keep hearing from other PE teachers?
Are you serious? Your muscles don't produce lactic acid. Your muscles only produce lactate.
So, what does a lactate do?
Lactate will escape from the muscles that you're working out to decrease the acidosis in that particular muscle.
Where is it heading?
Usually, pyruvate goes to the liver, but it can also go to other muscles in the body.
So, what you're saying is it's another cycle of like from pyruvate to lactate and then back to pyruvate again? Is that right?
Yes, you're right. This is the anaerobic lactic energy system.
Anaerobic means no oxygen, correct?
Yes, that's right. If you're working out and you're using strength to lift, pull, or move an object or your body, you don't need oxygen. But the reason why you can't last long in push-ups or curl-ups is because of anaerobic threshold. You can no longer go beyond once you feel your anaerobic threshold. That means the buildup of the hydrogen ions is overwhelming and pyruvate can no longer keep up in the muscles. You can only use anaerobic lactic energy system for 2 minutes or so, depending on your muscular endurance.
So lactate keeps me going when I am in the gym. Okay, so I understand now why I feel sore when I'm working out with weights.
Yes, that's right. But that is not because of lactic acid. That is because of hydrogen ions.
That's interesting. Hey Glucose, I have another question. I want to increase the size of my muscles. What should I do?
Don't ask me. I can only give you energy. Ask them.
Who?
Proteins.
Oh, okay. Speaking of proteins. Hey proteins, I want to grow my muscles. What should I do?
If you want to build huge muscles, yes, your body can use as bricks to rebuild your muscle fibers. But only when those weights in the gym cause micro tears to your muscle fibers.
But I don't want to do weights. I just want to do cardio.
Then sorry, we can't help you. Bye.
Oli G, if that's the activity that you want to do, you will need oxygen. The 2-pyruvate molecules and NADH will need the oxygen to enter the mitochondrion, the powerhouse of the cell.
So oxygen is like their password.
Knock knock.
Who's there?
Oxygen.
Oxygen too.
Oxygen. Bringing 2-pyruvate and NADH molecules, asking permission to enter the mitochondrion, sir.
So what happens in the mitochondria?
Well, that is a long process, Oli G. You probably need to ask your biology teacher to explain to you about Krebs cycle and electron transport chain.
I know it's a long process. I will make another video in the next season of Physiology. But how is the aerobic energy system related to sports and physical activities?
Well, the Krebs cycle generates about 2 ATPs and the electron transport chain produces 36. That's about 38 ATPs in total.
So that's more than the anaerobic lactic energy system.
Yes, and this is the reason why you can last long when you use aerobic energy system. Activities such as running, jogging, active sports are using aerobic energy system.
And this is just what I need to improve my cardiorespiratory endurance. So what if I want to lose weight?
If you want to lose weight, you can speed up burning those calories from your last meal through aerobic exercise.
How long would it take?
Depends on the intensity, but with aerobic exercise, it's 1 hour and 45 minutes to 2 hours.
That long?
Then after that, your body will tap your glycogen reserves.
Speaking of glycogen reserves.
Hello.
Hello, glycogen. So, I heard that you are...
Reserve.
Okay, I respect that, but tell me, if I keep going with my workout, how long can you sustain me?
Just 2 hours.
Hey, Oli G,
Look who's here! It's fat!
you're fat.
No, what I mean is, you're fat.
You're calling me fat?
I'll just call you the fat then. So tell me, is it true that if I put pressure on you, if I squeeze you, or target the part where you're located, is it true that you'll just get in the way?
Who told you that? That's not true. There's no such thing as spot reduction.
Oh, another question is, can I just remove you?
Do you mean liposuction?
Yeah, that's the word.
Well, if you can afford it and you're ready for some side effects, go ahead. But you can always use me as an energy. Turn me into ketones so I can be of use. After all, I'm not at all bad. You just make me look so bad because you are lazy. That's it.
Oh, okay. One last question. Is it true that you can transform yourself into muscles?
No.
Okay. Any last word, you guys? Glucose?
To all my 7 billion followers, please keep on eating and drinking me. I come in many forms. I'm in your favorite beverage, pasta, rice, bread, in fruits, but just don't get too much of me. Do you know what my super fans are called?
Gluconatics.
No. Diabetics.
Oh, that's not good.
Of course that's not good. You can't have too much of me.
Thank you, Glucose. Next up, Glycogen.
Well, all I can say is don't give in to food when I start working. I also want to be used up,
Thanks, Glycogen. Up next, Fat.
Well, all I can say is that I'm not what you think I am.
What are you?
I'm flabulous.
How about cholesterol?
HDL is good, but LDL
He's bad.
Is he the one who caused Uncle Jesse's coronary heart disease?
that surely was him.
So tell me how to keep you healthy then.
Well, to all my fans out there, eat unsaturated fat like avocados, olive oil, fish, and nuts. These are good for you.
Thank you for dropping by, guys. I really appreciate it. Let's give a big round of applause to glucose, glycogen, protein, and fat. So that's it, guys. If you have more questions about your body composition, the energy system, the physical activities and exercises that you can do to improve your body structure and health condition, send it to physiology@gmail.com. Thank you so much for watching and see you in our next class session. Bye!